There is a rock in a vault in Houston that should not exist. Sample 74220. The color of a dying ember, pulled from a world that is supposed to be the color of ash from horizon to horizon. It was found in 1972. Its full story wasn't understood for almost 30 years. It isn't the only thing like that. There are at least 5 discoveries from the moon that quietly broke everything we thought we knew. A soil sample that shouldn't be that color. A signal that shouldn't have lasted an hour. Ice where there shouldn't be a drop of water. A magnetic field where there shouldn't be one at all. And a piece of engineering we apparently forgot how to build twice. Almost none of them ever made it past a research journal. Nobody has ever fully explained why, until now. We tend to think of the moon as the settled case in our solar system. Grey, dead, fully mapped, fully explained. A rock we conquered once and then filed away. But settled cases don't produce active research papers 60 years later. They don't have seismometers detecting sounds no one can fully explain, or satellites finding water where there should be none, or magnetic fields where there should be nothing at all. The moon is not a closed file. It is an open one that we stopped reading aloud. Why did we stop? The official record points to budgets, priorities, a world that moved on to other headlines, but the record only tells you what happened. It doesn't tell you why the silence lasted so long, or why so much of what we did find never made it past a research paper. What we found waiting there was stranger than expected. Harrison Schmitt is the only professional geologist to ever walk on another world. NASA fought for years over whether to send a scientist at all, or whether every seat should go to a test pilot. Schmitt won that argument, and on the 3rd day of the mission, at the rim of a small depression called Shorty Crater, his training paid off in a single sentence radioed back to Houston. Mission Control's first assumption was that his visor was reflecting the sunset light of Earth, or that 6 days of lunar dust had scrambled the color in his camera. But Schmitt insisted. He scraped a trench with his boot, and beneath the gray surface dust was a layer of soil the color of rust, undeniable, vivid, entirely out of place on a world that is supposed to be the color of ash from horizon to horizon. Kneel where Schmitt knelt, and beneath your glove the gray dust of a dead world suddenly gives way to a color that has no business being there. As if someone had struck a match under the surface of the moon, and it never quite went out. He collected it. It came home, and yet, when scientists examined it, the orange soil turned out not to be evidence of anything living or anything geologically recent. It was older than almost anything else Apollo brought back, nearly 3.5 billion years old. The color came from millions of tiny beads of volcanic glass, flash-frozen mid-flight, thrown out of a fire fountain of lunar magma, in an eruption more violent than almost anything Earth has ever produced. A typical fire fountain on Earth, in Hawaii, might throw lava a few hundred feet into the air. The Taurus Littrow eruption is estimated to have thrown molten lava hundreds of meters into the air, in a vacuum, under a sixth of Earth's gravity, spraying droplets of glass across dozens of miles before they cooled and fell like orange rain onto a world with no atmosphere to slow their fall. Picture a fountain in a public square. Now imagine that instead of water falling back into the same basin, every droplet is flung so far and so fast that it lands in a different city, frozen mid-air the instant it leaves the nozzle. That is what those glass beads are. Raindrops from lunar fire, frozen the moment they were born, and untouched for 3.5 billion years until a geologist in a spacesuit noticed the wrong color at his feet. But this still isn't the strangest thing about the orange soil. The eruption that created it needed something to drive the magma upward so violently. Some gas, expanding underground, forcing molten rock toward the surface the way carbonation forces open a shaken bottle. On Earth, that gas is usually water vapor. The moon was supposed to be bone dry. its interior scoured of water in the violence of its own formation. So what was the gas? When later analysis pushed further into the glass beads trapped inside microscopic bubbles, they found the signature of water. Not much, but not zero, on a world that was supposed to have none. We were certain the moon was bone dry. We were wrong. That single orange sample would turn out to be the opening page of a much longer story, one that would take another 30 years to catch up to. It wasn't the only page NASA chose to leave unread. In 2019, the agency's Apollo sample curator, Ryan Ziegler, opened a different tube, a sealed core from the same Apollo 17 mission, untouched since 1972, saved deliberately on the bet that some future generation would have instruments good enough to ask it questions Apollo-era scientists couldn't. That generation turned out to be this one. 3 years earlier, in November 1969, Apollo 12's astronauts did something almost administrative on their way home. Before leaving lunar orbit, they jettisoned the ascent stage of their lunar module, the upper half of the spacecraft that had carried them off the surface, and let it fall back down, crashing into the moon roughly 40 miles from where they'd landed. It was meant to be a footnote, a piece of hardware they no longer needed, disposed of on the way out the door. But Apollo 12 had left something behind on the surface, a seismometer placed there specifically to listen. When the ascent stage struck the ground at roughly 4,100 miles per hour, the instrument recorded the impact, and then it kept recording, and recording, and recording. An impact like that on Earth would register, shake the ground for a few seconds, and fade into silence as the vibration is absorbed by wet, layered, structurally complex rock and soil. Mission scientists expected the same brief signature on the moon. Instead, the seismometer picked up reverberations that lasted for nearly an hour. The signal didn't spike and die. It rose slowly, sustained itself, and only gradually tapered away. The unmistakable signature not of an impact, but of something ringing. Back in Houston, one scientist reportedly turned to a colleague and said the moon sounded as though it were ringing like a bell. The phrase stuck and has followed the discovery ever since. For a brief moment, before the data was fully understood, some on the team genuinely didn't know what they were looking at. A signal that should have died in seconds was still going after 10 minutes, then 20, then 40, and no one in that room had ever seen an impact behave that way before. It is one thing to expect the unexpected in theory. It is another to watch it happen live on an oscilloscope, with no immediate explanation for why it hasn't stopped. Strike a wine glass and it sings for a moment before falling silent, the sound dying quickly because the glass is small and imperfect, full of tiny defects that swallow the vibration. Strike a tuning fork, precisely made from a single piece of dense, uniform metal, and the note holds far longer, humming steadily in a way a wine glass never could. The moon, it turned out, was behaving less like the glass and more like the fork. The explanation scientists eventually settled on wasn't supernatural. It came down to two things Earth simply doesn't have: no water to dampen and fracture the interior, and none of the loose, layered sediment that breaks vibration apart the way insulation muffles sound in a wall. The moon's interior is comparatively dry and structurally uniform, closer to a solid block than a layered planet, and that uniformity let the shock of the impact travel and resonate far longer than anyone expected. It is, in other words, a real and explainable phenomenon. And still, it took an accident, a piece of hardware nobody wanted anymore, to prove that a world could hold a note for nearly an hour after being struck. The seismometer network that caught the moon's ringing wasn't a single instrument. It was a set of stations placed across 4 Apollo missions, designed to run for a year and then be switched off. NASA kept them running for 8, until 1977, when a budget review in the middle of the economic strain of the late 1970s ordered them shut down to save the cost of the ground staff needed to monitor the data streaming in. Scientists were still finding new lunar impacts and quakes in the archived data when the plug was pulled. The network wasn't switched off because the mystery was solved. It was switched off because the invoice came due. For nearly 30 years afterward, the moon fell silent to us. Not because it stopped shaking, but because we stopped listening. And silence, it turns out, is not the same as nothing happening. While we weren't listening, an entirely different kind of evidence was about to surface. Not from the ground shaking, but from something that shouldn't have been there at all. That silence was broken slowly, mission by mission, starting in the 1990s, as a handful of orbiters returned to lunar orbit for the first time since Apollo. And in 2009, one of them made the discovery that the orange soil of Apollo 17 had hinted at almost 40 years earlier. India's Chandrayaan-1 orbiter carried an instrument called the Moon Mineralogy Mapper, built to study the mineral composition of the lunar surface by analyzing the wavelengths of sunlight it reflected. It was not designed as a water hunt, but as the data came in from across the surface, not just the shadowed poles, but places touched by direct sunlight, the spectral signature kept showing the same unmistakable absorption pattern associated with hydroxyl and water molecules bound into the very grains of surface soil. This broke the model completely. The moon was supposed to be desiccated by the violence of its formation, then further scoured by billions of years of direct solar radiation with no atmosphere to protect it. Water should not have been able to survive on the sunlit surface at all. And it got stranger. Within the deepest, permanently shadowed craters near the lunar poles, places so cold and so untouched by sunlight for billions of years that some register among the coldest measured temperatures anywhere in the solar system. Instruments detected not just trace hydroxyl, but genuine water ice mixed directly into the soil. Early estimates suggested a few 100 million metric tons of ice locked in shadow at the lunar South Pole alone. Later missions have refined that further, and some assessments now put the total volume of accessible water ice at the poles in the billions of gallons. Enough, in principle, to support a permanent human outpost, and enough to be split into breathable oxygen and rocket fuel without a single drop brought from Earth. Picture the driest desert on Earth, the Atacama in Chile, where some weather stations have never recorded a drop of rain in the history of measurement. And imagine that in its coldest, most shadowed canyon crevice, frost still forms every night. That is roughly the paradox the moon presented us. A world with no atmosphere, no protection, no reason to hold water at all, quietly hoarding it in its darkest corners for billions of years. Stand at the rim of one of those polar craters, and you would be standing at the edge of a pit that has not seen direct sunlight since before complex life crawled out of Earth's oceans. A darkness older than trees, older than bone, holding inside it the raw material for drinking water and breathable air on another world. The scientist most associated with confirming this data, Carl Peters of Brown University, had spent years building instruments for exactly this kind of subtle spectral signal hunting, only to watch mission after mission get cancelled or descoped through the 1990s for lack of funding. When Chandrayaan-1's data finally came back showing the signature she'd spent a career chasing, colleagues have described her response not as triumph, but as quiet disbelief, the reaction of someone who had stopped expecting to see the answer in her lifetime. The moon, taken as a whole, has no global magnetic field, unlike Earth, whose molten iron core generates a magnetic bubble that deflects solar radiation and gives us the northern lights. The moon's interior cooled and solidified long ago, and by every model, its field should have died with it. Earth's surface magnetic field measures somewhere around 25,000 to 65,000 nanotesla. Depending on where you stand, the moon on average measures next to nothing, a few nanotesla at most, a rounding error by comparison, exactly what you'd expect from a world with no active core engine left. That was the baseline. That was supposed to be the whole story. It isn't, and yet scattered unevenly across the surface. Concentrated disproportionately on the far side, the hemisphere permanently turned away from Earth, are patches of magnetized rock strong enough to visibly alter the surface itself. The clearest example is a formation called Rena Gamma, a bright, swirling, almost marbled pattern etched across the lunar surface. With no crater, no raised terrain, nothing to explain its shape through impact or erosion. It looks, from orbit, like cream stirred into coffee and frozen mid-swirl. For decades, no one could fully explain why it was there, or why it was bright, when the surrounding terrain was dark. The leading explanation is that the swirl sits atop a localized pocket of magnetized rock, a leftover scar from some ancient, more active magnetic field the moon may once have had, deflecting the stream of solar wind particles that otherwise darken and weather lunar soil over time. Where the magnetism is strongest, the particles are pushed away, and the soil stays lighter, brighter, protected. Imagine a shoreline exposed to the same tide and salt spray for 1,000,000 years, except for one patch shielded by a rock outcrop, which stays clean and pale while everything around it weathers dark. The swirl is that shielded patch, written across an entire lunar landscape. Some regions on the far side show localized magnetic field strength measured in the hundreds of nanotesla, dozens to over 100 times stronger than the faint magnetism found almost anywhere else on the moon's surface. Concentrated in patches only kilometers wide, on a world that isn't supposed to have any working magnetic engine left at all. Still a fraction of Earth's field, but on a world with none to spare. A fraction is a mystery in itself. The scientist most associated with the leading hypothesis, Mark Weisach, proposed the answer in a 2012 study in the journal Science, the South Pole Aitken Basin, one of the largest impact craters in the entire solar system, over 1,500 miles across, was struck by an impactor carrying iron-rich material, and the shockwave of that collision, while the moon's core still had some residual magnetism, flash froze a magnetic signature into the surrounding rock at the moment of impact. If that is correct, the far side of the moon is not simply blank and featureless, as it appeared to the first observers who saw it. It is a fossil, a frozen photograph of a magnetic field that no longer exists, taken in the instant of one of the most violent collisions in the moon's history, and preserved, untouched, for longer than complex life has existed on Earth. And if a magnetic field can leave a fossil imprint on rock, the question becomes uncomfortable in a different direction. What else did the moon preserve in the last few billion years that we simply haven't found the instrument to read yet? There is a persistent claim, repeated across the internet for decades, that NASA lost the blueprints to the Saturn V rocket that carried Apollo to the moon, implying the plans vanished, filed away or destroyed, the knowledge gone. It isn't quite true. Microfilmed drawings, technical reports, and manufacturing documentation still exist today, held across NASA centers and the National Archives. But something did disappear, and it is, in its own way, more startling than a missing folder of blueprints. A rocket is not a drawing. It is the product of an entire industrial ecosystem. Specific alloys smelted to exact tolerances by suppliers who have since closed, custom tooling and jigs, built once, used for years, then scrapped when the program ended, and, most irreplaceably, tens of thousands of engineers, welders and machinists who carried in their hands the accumulated judgment of a decade of trial, error and refinement that no document fully captures. In May 2013, conservators working on wreckage Jeff Bezos's team had pulled from 3 miles down in the Atlantic, found something under a black light, a stenciled serial number, invisible to the naked eye, corroded but still there after more than 40 years underwater. 2044. Cross-checked against Rocketdyne's records, it confirmed the engine had flown on Apollo 11 itself. Bezos would later describe the wreckage on the seafloor as an underwater sculpture garden of twisted engines, the physical evidence of exactly how violently that hardware had come apart decades earlier on its final fall into the Atlantic. Imagine you have the complete written recipe for a legendary dish, passed down exactly as the original chef wrote it, but the chef who somehow knew by feel exactly when the dough was ready, or exactly how hard to fold the batter, has been gone for 50 years, along with everyone who trained under them. The recipe survives. The hands that knew how to read it instinctively between the lines do not. If you were handed the full documentation of the Saturn V's F1 engine tomorrow, every schematic, every tolerance, every material specification, you still could not simply build one. Separately, that same year, a team of Marshall Space Flight Center engineers pulled an F1 gas generator from NASA's own inventory, 3D scanned it, rebuilt the part using modern manufacturing, and test-fired it. Not because the drawings were missing, but because the specific manufacturing know-how behind the original had to be rebuilt from the physical object itself, piece by piece. The Saturn V remains, to this day, the most powerful rocket ever successfully flown, generating over 7.5 million pounds of thrust at liftoff. Powerful enough to send a payload heavier than a fully loaded Boeing 747 not just into orbit, but out of Earth's gravity entirely, on a course for another world. It flew 13 times, and despite one in-flight engine anomaly on Apollo 13's ascent, it delivered every crew safely to its intended trajectory. And the precise combination of institutional knowledge that built it existed, in its complete form, for barely a decade before it began to disperse. We did not lose the moon rocket. We lost the specific constellation of human beings who knew how to build it. One retirement, one closed factory, one forgotten shortcut at a time, which raises the real question underneath all 5 of these files. If we can lose the knowledge behind the most powerful machine we ever built, in barely 50 years, with the paperwork still sitting in an archive, what does that say about everything else sitting in that archive, waiting for someone to look again? Put these 5 findings side by side, and a pattern starts to emerge. Orange soil, collected in 1972, waited decades for instruments precise enough to find water trapped inside it. A seismic signal, recorded in 1969, went quiet when the network that caught it was switched off, its questions unresolved when the funding ran out. A magnetic anomaly, visible in every photograph of the far side since the first orbiters passed over it, waited for missions capable of mapping it in enough detail to even propose an explanation. Water at the poles, hinted at by orbital data for decades, wasn't confirmed until an instrument built for an entirely different purpose happened to catch its signature. And a rocket engine, fully documented on paper, still had to be pulled from the ocean floor and studied like a fossil because the humans who understood it firsthand were gone. Every one of these findings exists in a record somewhere. But somewhere between the discovery and the public, each one went quiet. Some to budget cuts, some to a lack of instruments, one to an ocean floor. Whether that's coincidence, neglect, or something this file still hasn't accounted for, is a question the record doesn't fully answer. The file was never locked. It was just left open on a desk we walked away from, and nobody has fully closed it since. There is something worth sitting with in the fact that the nearest other world to our own, the one place beyond Earth that 12 human beings have actually stood on, touched, and carried pieces of home from, still holds open questions after everything we've done to answer them. We tend to imagine discovery as a door that swings open once and stays open. But the moon suggests something quieter and more patient, that some doors open only part way and stay that way for exactly as long as we're willing to keep looking through the gap. The orange soil is still in its vault, The seismic archive is still being combed for signals no one has explained. The ice at the poles is still waiting for the first human boot to test it. And somewhere in the gulf between the blueprints of the most powerful rocket ever flown and the knowledge of the people who built it, something was lost that no document can fully restore. 60 years after we first left footprints on another world, the moon is not finished telling us what it knows. We simply have to keep listening.